Welcome, everyone. Today, we're going to delve into one of the most fundamental and, frankly, indispensable tools in all of business mathematics, break-even analysis. Now, you might have a brilliant idea for a product or a service, but the question that separates an idea from a viable business is this: at what point does it actually become profitable? By the end of our lecture today, you'll not only understand the mechanics of this calculation, but more importantly, how to use it as a strategic compass for making critical business decisions. So, here is our roadmap for today. We'll begin by framing the fundamental question that every single venture must answer. From there, we'll establish a precise academic definition for the break-even point. Then we'll roll up our sleeves and work through a practical calculation. After that, we'll explore what that number truly means from a strategic perspective. And finally, we will discuss some of the common pitfalls I see students make so you can avoid them in your own analyses. All right, let's start at the very beginning. Before investing a single dollar, before hiring a single employee, every entrepreneur, every manager must confront this question. Is this idea viable? It's not about whether the idea is good, it's about whether it can sustain itself financially. At what point do we transition from losing money to making money? This is the core question that break-even analysis is designed to answer. At its most basic level, every business operates in one of two financial states. You're either generating a profit or you're incurring a loss. There is, however, a crucial tipping point, a razor's edge between these two states. Understanding precisely where that line is drawn is absolutely fundamental to managing a business, to planning for growth, and to ensuring its very survival. This brings us to our second section. Let's formally define this concept. What exactly is this break-even point? Having a clear, unambiguous definition is critical, as it forms the bedrock of all the calculations and strategies that will follow. So here is the textbook definition. The break-even point is the specific level of sales at which your total revenue, all the money coming in, is exactly equal to your total costs, all the money going out. At this point, your profit is precisely zero. You haven't made any money, but crucially, you haven't lost any either. It's a state of financial equilibrium the moment a business becomes self-sustaining. Now, to accurately calculate this point, we must first understand the anatomy of total costs. We dissect them into two distinct categories. First, we have fixed costs. Think of these as the costs of simply opening your doors for business each month. Your rent, your salaried employees, your insurance premiums, these costs remain the same whether you produce 1 unit or 1,000 units. On the other hand, we have variable costs. These are directly tied to your production volume. For every single unit you create, you incur a variable cost. The raw materials, the direct labor to assemble it, the packaging. The more you produce, the higher your total variable costs become. Distinguishing between these two is absolutely non-negotiable for a correct analysis. And this simple, almost elegant equation is the mathematical heart of our entire analysis. This is the state of equilibrium we are trying to solve for. Our goal is to find the quantity of sales that makes the left side of this equation perfectly equal to the right side. All right, enough theory. The best way to truly grasp a concept like this is to apply it. So let's build a small business right here, right now, as our case study. We're going to launch a hypothetical custom t-shirt business and calculate its break-even point together. We're going to follow a very deliberate four-step process. First, we'll identify and sum up all of our fixed costs. Second, we'll determine the variable cost for each individual unit we produce. Third, we'll establish a selling price. And only then, once we have all those components, can we apply the break-even formula. Okay, step one. Let's assume after our research, our fixed costs come out to $1,200 per month. This could be, say, $800 for workshop rent, $100 for our design software subscription, and another $300 for basic utilities and insurance. The key takeaway here is that at the end of the month, we owe $1,200, regardless of whether we sell a single shirt. Step two are variable costs. For each t-shirt, we have to buy the blank shirt itself. Let's say that's $4. We use $3 worth of ink and printing supplies, and the packaging for each shirt costs $1. So our total variable cost per unit is $8. If we make 10 shirts, our variable costs are $80. If we make 100 shirts, they're $800. You see that direct relationship. Step three, the selling price. Now, pricing strategy is a whole other lecture, but for our model, let's say based on market research and our brand's perceived value, we decide to sell each custom t-shirt for $20. This is our revenue per unit. And now we arrive at the formula. We take our total fixed costs and divide them by the quantity in the parentheses, selling price minus variable cost per unit. Now, this denominator is an incredibly important concept in itself. It's called the contribution margin per unit. For us, that's $20 minus $8, which equals $12. Think of it this way. Each shirt we sell contributes $12 towards paying down that big $1,200 mountain of fixed costs. It's not profit yet, but it's the money that gets us closer to profitability. So let's do the math. We take our $1,200 in fixed costs and divide by our $12 contribution margin. The result is 100. This means we must sell exactly 100 shirts per month to break even. At the moment we sell that 100th shirt, our net income is zero. We are perfectly financially balanced. Now, here's where we pivot from being mathematicians to being business strategists. 100 shirts isn't just the answer to an equation, it's a critical piece of strategic intelligence. What does this number actually tell us about our business? This chart visualizes the story perfectly. Look at the bar on the left. If we only manage to sell 50 shirts, each one contributes $12 for a total of $600. But our fixed costs are $1,200. The result? A $600 loss. Now, look at the middle bar. At 100 shirts, we've generated exactly enough to cover our costs. We're at zero. And here's the beautiful part. Look to the right. For every single shirt we sell beyond 100, the 101st, the 150th, the 200th, that entire $12 contribution margin becomes pure profit. At 150 shirts sold, we've made a $600 profit. So, as future managers, how will you use this? Well, first, you can set tangible, meaningful sales targets. The team now knows job one is to sell 100 units to keep the lights on. Second, you can make informed pricing decisions. What happens if we raise our price to $22? Our margin becomes $14 and our break-even point drops to about 86 shirts. Is that achievable? You can evaluate cost changes. If the price of blank shirts goes up by $1, you can instantly calculate the impact on your break-even point. And perhaps most importantly, you can assess the risk of new ventures. If an analysis shows you need to sell 10,000 units a month just to break even, you know you have a high-risk venture on your hands. Now, for our final and perhaps most practical section, let's talk about where this analysis can go wrong. A model is only as good as its inputs, and I want to equip you to avoid the common traps that can render your analysis useless or worse, misleading. Here are the big ones. First, forgetting to include all fixed costs. Did you remember the annual web hosting fee, the business license? They all count. Second, miscalculating variable costs. A classic mistake is forgetting things like credit card processing fees, which are a percentage of every sale. Third, assuming a static environment. In the real world, costs for raw materials fluctuate, and you might need to adjust prices. This is a dynamic, not a static analysis. Fourth, ignoring the market. Your analysis might say you need to sell 5,000 units, but if the total market is only 6,000 units, that's a problem. And finally, the biggest mistake of all, treating the number as the final answer. The number is the start of the strategic conversation, not the end of it. This quote from your course text actually provides a bridge to more advanced microeconomics. Marginal revenue is simply the revenue from one additional unit sold, in our case, the $20 selling price. Marginal cost, in this context, is the variable cost of that one additional unit, our $8. The break-even analysis helps us see how the contribution from each sale, that difference, works to cover our fixed or non-marginal costs. It's a foundational concept that you'll see again in more advanced courses. So I'll leave you with this final thought exercise. Imagine you complete an analysis and your break-even point is 500 units a month. My question to you is that good or bad? And the only correct answer, of course, is it depends. It depends on the context. How large is the market? What is your production capacity? How aggressive are your competitors? Is selling 500 units a month a reasonable goal, or is it a monumental task? You see, the break-even number itself is meaningless without context. Its true power lies not in giving you an answer, but in forcing you to ask the right strategic questions. And that is the mark of a skilled business analyst.